thank you so much for being here, and thank you, Yanni, for that kind introduction as well as the invite for being here. Matt was way too kind yesterday when he talked about AFRL's contribution to this wonderful event in Q2B, and it's great to be back here for another year. We always look forward to coming every year and participating. We go to a lot of events, but this one is certainly special to us in that it just provides a great atmosphere and a forum for not only talking about what we do, but really the exchange of information and ideas and the development of new partnerships as well as curating existing partnerships as well. And that's what I really want to focus in on my talk today as well, is really talking a little bit about what we do at AFRL and our technologies, but also what we do in terms of partnerships, what we do in terms of workforce development, and kind of going along those angles. I'll be here all week as well, so happy to discuss this information as well and any questions you may have or thoughts. I have a wonderful team with me here this week as well. Really want to thank them for their assistance and help and creativity in putting these slides together. Dr. Don Teleska, Ms. Laura Wessing, and Dr. Matt LaHaye. They're here as well, so please look them up if you'd like to talk further about this as well. So let's get into this. A lot of people here in the audience, I'm sure, have seen this slide before in terms of why we do quantum in the Air Force. And it's an older slide, but it hits the mark, right? We've modified this through the years, but we're really proud of what it still shows in terms of our capabilities. So you'll see in the upper left-hand corner, the 4 key areas that we work on color-coded: timing, sensing, networking, and computing, linked together by workforce development as well as supply chain enhancement development as well as technology development, or really the continued R&D there as well. I'm going to go in later on, next slide, talking a little bit more about specific technologies that make that up. But here on this operational V1, or OV1 as we call it within the Air Force, what are our key focus areas here? So let's start with timing and sensing. So you'll see, based on their color codes, long duration, unaided inertial navigation. So when we're not able to operate in permissive GPS environments, we have denied or degraded environments, we see ourselves as being able to use quantum-enabled technologies, quantum-enabled PNT with very precise clocks, new sensors, to be able to bring that to fruition as well. Also of interest, certainly across the Air Force as well as our other tri-services, bunker tunnel detection with advanced sensing techniques certainly come into play there as well. Networks, right? Key driver for us. Dr. LaHaye gave an excellent talk yesterday on the Air Force's interest in networks. Hopefully you saw that. Really here we're focused in on security and being able to provide low probability of intercept type communications, certainly be able to secure our information through new encryption techniques. Here I'd specifically like to point out we're focused in on entanglement distribution, really going on beyond QKD, which we do not work on within the Air Force. So in addition to securing the information, what else do we see ourselves with networks? So certainly bringing together disparate clocks, disparate sensors, bringing together those technologies for new capabilities. And then certainly as well, distributed types of computing systems. We see that really as a near-term applications. Certainly a lot of commercial partners out there are working on those applications, and I think that's going to be really key going forward as well. And then finally, computing, shown here is just kind of a block diagram. We'll get into it a little more of why we're interested in computing. But certainly, being able to solve problems, as Dr. Preskill talked about, that we can't solve today, and how can quantum enhance that? And we see ourselves in really 3 areas. Here, of course, of most interest would be logistics type of operations, optimizing over very large scale and large number of parameters as well. But also things like material science, material discovery would come into play there in terms of quantum simulation. And then finally, enhanced machine learning, which would bring all sorts of new capabilities to the fight as well. All right, so let's dig a little bit deeper here. I love this chart in terms of the fact that it really shows, time frames for these technologies. So left-hand side here, self-sustained PNT, which we talked about. Timing, things are already out there, 1 to 3 years. Sensing, probably around the order of 2 to 5 years. Let's focus in on that piece of the chart first off. So what we do in timing across AFRL are clocks. Great clocks are already out there. You can think of the NIST standards, what JILA has developed, billions. It doesn't lose time over tens and billions of years. It's just unfathomable to think about that. Well, with that comes a price, right? Very large scale rooms housing all that equipment to get to that stability and precision. We, of course, can't afford that in the Air Force, so we need to turn to new types of technology that is much more scalable and field deployable. So going beyond things like GPS clocks now, which are stable on the order of nanoseconds, but require enhancements or require refresh several times per day. We can't afford that within the Air Force. We need the precision, the enhanced stability, as well as lower refresh rates as well. So that's where we're really targeting. I'll show an example later on of some field tests that we did with that. Sensing, similarly, inertial navigation systems right now, probably stable without being refreshed on the order of hours to a few hours. We need to go beyond that when we think about our missions and our potential mission spaces, where we'll need to go and have stability and know where we are for multiple hours, maybe even days on time as well. So working on things like magnetometers and accelerometers are key investments for the Air Force there as well. Networking, we ship to the other side here, a little further out, 5 to 10 years. And then as we heard in previous talk by Professor Preskill, certainly fault-tolerant quantum computing, 10 plus years, horizon kind of unknown there, although the technology is moving pretty quickly. 3 areas of technology under development, under networking, 3 qubits that we're looking at in terms of developing a heterogeneous network would be integrated photonics, trapped ions, and superconductors. And really, how do we do the translation between those, or the transduction between those elements, bring them together to form that network. So we have a very strong team working on that. Dr. LaHaye did a great job yesterday detailing the work in there. And then finally, computing. We don't build quantum computers within the Air Force, but we go out and we access and we leverage what our commercial industry is doing. So 2 of our key partners out there right now that we work with is certainly IBM. We've talked a lot about that in past years. They've been a great partner for us. 4+ years that we've been a hub on the IBM Quantum Network. Not only us within the Air Force working on those technologies and using the systems, but also the partners we're able to bring to that. We have 13+ partners right now that work with us on related problems. And then the Navy as well. We signed an agreement, this is new since last year, where we have over 6 naval centers partnered with us in addition to NRL, working on computing technologies. Another partner for us, which we've recently announced, is IonQ, a trapped ion system. So we're just getting into the access right now with that, and we're really excited to see what will become of that technology as well. So a little bit about AFRL. Let's take a step back. AFRL is a very large organization. There's about 10 locations throughout the U.S. What do we do for the Air Force, right? So Air Force Research Laboratory, we invent the future for the Department of the Air Force. And by that I mean not only the Air Force, but also the Space Force as well. So bringing together those 2 services is very key for us in what we do in AFRL. So 6 different directorates, those 2-letter acronyms. We're the Air Force, so we got to have acronyms for pretty much everything we do. You see them listed there. In the parentheses are the names of the directorates that work on these different types of technology. So if you think of the diagram on the previous page, kind of shown here as well. Work in a directed energy directorate where we're doing satellite-based communication systems, ground to satellite. Information directorate, which I'll go into more detail in a slide here. We're really computing, communications, and networking systems. Sensors directorate, also at Wright-Patterson. Quantum emitters, device fabrication. Space vehicles is really where we go into the sensing and the clocks. That's located in Albuquerque, New Mexico, as shown on the slide. And then, kind of those crossbars on the other page, the materials development, the supply chain work. That's really done by our materials and manufacturing director, and also working on some magnetic sensors as well. I'd like to focus in a little bit here on our 2 things. One is our international sites, 5 international locations for AFRL. You see them listed there. Previous years, we had 3. We're now on to 5 as well. A couple of things there. Tech scouting, looking at technologies being developed across the world, mostly in academia. But how can we nurture those? How can We provide funding for those, further develop them, mature them, and then ultimately leveraging them within AFRL. And then specifically the Information Directorate, where I'm based in Rome, New York, center of New York State. Talked about the network technologies being developed there, as well as the access to the commercial computing systems. But I'd really like to focus in on two things there. One that's brand new is the stand-up of our extreme computing facility. Pretty interesting name that we came up with, I think. This has been in the works for many years, but this was really the rollout of 3 new quantum laboratories within our fence line, if you will. And this allows us for the development of those networking technologies, as well as the transduction work between those. And specifically, we all know in this room how difficult it may be in terms of environmental control, humidity control, vibration control, all that goes along with that. So being able to build state-of-the-art labs for that was very key. Closely tied, why we call it extreme computing or other non-von Neumann architectures such as neuromorphic computing, nanocomputing, using memristive technologies, also under development there, as well as machine learning technology. So certainly saw some great talks yesterday on the convergence of machine learning and artificial intelligence and quantum technology. So I think for us, that's going to be key as well. Innovari Advancement Center, also a great facility offsite for us to really leverage our non-traditional partners, our international partners, being able to work with foreign nationals side by side with our engineers. We have 2 state-of-the-art large laboratories there. Also coupled what we call SkyDome, very large facility for UAS testing, former B-52 hangar. So if you think of a B-52 and the magnitude and scale of that, that's what that test facility is. Those facilities don't belong to us. They're actually funded by Oneida County with funding through New York State as well to set up and maintain those facilities. And then also our federal partners have allowed us to really equip and develop state-of-the-art technologies in there as well. So moving on to some of our ways to partner with the Air Force. You can read through there. We begin as early as certainly with our STEM activities. Small businesses, I'm going to go back and touch on that. Agreements, cooperative research and development agreements, and educational partnership agreements are key ways that we partner without exchange of funding. And then certainly other ways as well. It would be contracts, grants, certainly patent licenses, commercial test agreements, and then our innovation facilities, which I just briefly talked about as well. SBIRs, STTRs, very key to us. What I'd like to hit upon here and talk a little bit about is we held a great event in 2020, right during the pandemic. It's great timing on our part. But to me, it was a once-in-a-lifetime opportunity where we were able to do phase 1 and phase 2 STTRs to the tune of a total of $40 million, $35 million for phase 2, $5 million for phase 1, across the 4 different technology areas. Really allowed us to mature and to take some seed ideas and develop them. And I'm going to highlight some of that in the coming slides. But certainly as we move forward through some of our other partners as well, this has been great for us as well. So speaking of partners, strategic partners, I could spend all day talking about this, and everyone can go look for their logo up there. One of the things we're all about within AFRL and the Information Directorate, and certainly across the larger enterprise, is strategic partnering. That's one of the things that I certainly pride myself on in my current role with the quantum team, is developing those partnerships, but also nurturing them so that we can get really value for the Air Force out as well. So it's been great just yesterday, and I know today I've been meeting with a lot of our partners who are here, really just kind of brainstorming, not only talking about current results, but future work planned as well. So here I want to highlight in the next 4 slides, really for the remainder of my time, is talk about a few recent successful partnerships. So the folks I'm going to talk about, some are in the audience today, may not even know that they're going to be up here today, but really proud of what we've been able to accomplish. And again, I could spend all day taking that last slide and translating it here. So this is just a snapshot of what we talked about. So first off, I teased this in the past, RIMPAC 2022 exercises. So back in 2018, the commander of AFRL came to me, as well as Colonel Tim Lawrence, our director at the time and commander, and said, hey, we really need to think about moving quantum technologies out into the field. How can we get it out there faster? So he brought together the Navy and the Army, formed an alliance there, and to make it even more challenging, he said, let's bring in our partners. So we brought in our TTCP partners, or our Five Eyes partners. So in addition to the US, we had Canada, New Zealand, Australia, and the UK. Examples of what happened there. So we started work in 2018, 2022. We did a 3-week exercise out off of Hawaii in the Pacific. Some excellent results were achieved. You could see on the far left a ship that New Zealand had provided, custom-built shipping container by Office of Naval Research, was built to house the equipment that we went out and tested. So, can't stress enough how important it was to do those tests out and really see, especially as we think, military technologies, DoD technologies, from the lab out into the field. So what were some of the results? So middle part shows the optical clock. ORF, as it's affectionately called, optical rubidium atomic frequency standard, developed by our Space Vehicles Directorate in Albuquerque. Excellent results were achieved. It surpassed what we thought we'd be able to do, so we're very proud of that. Also did some quantum accelerometer testing there as well. So that was the Air Force's piece of it. Navy's piece of it, led by Dr. Tommy Willis, is shown there. 2 key pieces there were a vector atomic gravimeter coupled with a COTS inertial navigation system, brought those 2 together. And what we really found was some excellent results. One in terms of bias stability, form factor as well, and really saying, all right, these are promising technologies. So very much encouraged by what we saw from RIMPAC, and we're going to continue the tests out in the future. QNECT, I'm starting to run a little low on time, so I'm going to have to probably buzz through these a little quicker than I wanted to. But we did a test with QNECT last year, just over a year or so ago at Griffiths at our business technology park, using Innovare and using our partners with Oneida County. And here we're able to take a commercial product that QNECT had developed, again going back to our Quantum Collider event, those STTR awards, the QAPC, so the auto polarization compensator. And what that really does is it takes commercial fiber that's out there and compensate for polarization, which is critical to entangled photons, and able to transform those channels and compensate for the perturbations and instability in those fibers. So excellent technology. We did a 24-hour test with QNECT there, 95% channel fidelity and 98% uptime throughout those 24 hours. So it's a commercial product now, so really kind of shows that success cycle through it all. AIM Photonics been another great partner for us as well. So this was developed in 2015. So I think back to early in my career when we had very large optical tables, and we always dreamed and envisioned how we could put those into integrated chips. And here it is. You can read through some of the work that's been done there. So really a great collaboration between AIM, AFRL, and the Rochester Institute of Technology, and how we could take really classical integrated platforms, if you will, and move it into the quantum regime as well. So one of the key areas here that's been developed is this quantum flex PDK and MPW platform. Really excited about this. We did the first public release just this past fall, so some new info that I'm releasing here. Partners were selected. Those that are going on the ride are now in place. We're going to be in the fab in January. What's really cool about that is the fact that this will now be opened up to the public later on as well. So more to come on that, but you can see, reducing the cost, 10x improvement in loss as well. So this has been a key driver for us. Last partnership I really want to highlight would be our work with Rigetti and Purdue. Dr. LaHaye talked a little bit about this yesterday, but a great way for us to access the fabrication capabilities at Rigetti. So we started this relationship in about 2020. We just signed in September of this year a new 5-year agreement with Rigetti, which allows us the components that are highlighted right there in terms of the transmons, the couplers, the single microwave photon emitters and detectors, the entanglement sources, and how we can really design and then rapidly fabricate and test those in our systems and at Rome and at Innovare. And then finally with Purdue, how do we work that transduction element? So with their Behave group, being able to look to couple and transduce the microwave information into a photonic channel as well. So first generation complete there as well, and we look forward to talking more about those results in the future. And then finally, workforce development. I'm flat out of time here, but really, if you're interested in internship programs, please see me as well as our team this week. Lots of great opportunities, not only in Rome, but across our different directorates as well. And then also, which is not up here, summer faculty opportunities. We have a huge quantum summer faculty program and internship program across AFRL. So if you're interested, again, please see me, and look forward to talking to folks more throughout the rest of the conference. Thank you.